In this video, we are going to talk about inverse functions. Okay, so an inverse function of a one-to-one function, f of x, is a function denoted f inverse x. All right, so that's an f with a minus 1 up in the superscript position. And it has the property that f inverse of f of x equals x. All right, so what does this little condition here say? Well, it basically says that if I take any number, right, and plug it into f, okay, and I will get some output. And if I take that output and plug it into the inverse function, I will wind up with the number that I started with again, okay? All right. Another way of looking this is a composition of two functions, right? If I take the function f of x and I compose it with f inverse, I'll wind up with the function x in there. Okay, so there's sort of two ways to think about this. One as inverse function values, right, with numbers, and the other is with the functions themselves. And we will talk about both of those ways of talking about it. Okay. All right, and so in the next slide, we'll look at a very specific example, and it will probably make a little bit more sense to you exactly what we're talking about. Okay, so just a couple of things before we get to that example. Number one, right, this symbol is read as f inverse. Okay, it is kind of a bad choice of notation for this. Okay, because it's very, very easy to get this confused with -1 as an exponent. Okay, so if you had an expression like x to the -1, right? That's not a function in and of itself. It's not written in function notation. So in that context, they're talking about 1 over x. Or if you had 2 to the -1, right? In that context, that's just the number to the -1 power, right? So that would be 1/2, okay? But here, when they write it like this, right, in this context, they give you a function. They're talking about a function f of x, right? And then they start talking about f inverse, right? That is in no way related to this topic up here. It's a completely separate idea. Okay, so that's a little bit confusing, but if you think about how, like, say, the English language works, there's lots of words that are spelled exactly the same, but mean completely different things, right? Like this word. Are you talking about a guitar or a fish, right? And so and the normal way that you tell that in English is from context, right? You look at the words around it and decide, right? If they're talking about fishing, well, they're probably talking about this fish. If they're talking about music, right, they're probably talking about the instrument or timbre or whatever, okay, related to music. And so that's almost exactly the same thing here, right? So if you see this as a function that they're talking about. Hey, here's a function f of x, and then they're using this notation, right? Then they are talking about the inverse function, right? And it's not an exponent like this. It does not mean 1 over f. Okay. All right, an important point here also is that not all functions have inverses, right? Only one-to-one functions have inverses. So that's why we went back and reviewed a little bit about one-to-one functions, okay? So again, not every function has an inverse. Only one-to-one functions do. All right, so that's some of the background. So now let's look at a specific example. So in this example, I am giving you a function f of x, 2x minus 3, and I'm just telling you, hey, its inverse is this function right here, x plus 3 over 2. All right, so don't worry about how I came up with this. I am going to show you exactly how I came up with this later, or how to come up with it, right, the process. But for right now, don't worry about it, okay, how I came up with this. what I want to show you here is how are these two things related? What is the relationship between f of x and f inverse? I told you in the last slide, but this example to me makes it clear in the simplest of ways what the relationship between these two things is, okay? All right, so let me get this so I can write on it. All right, and so I want to find some of these function values. F of minus 2. All right, so to find f of minus 2, I would plug that in right to this formula. And get that. So 2 times negative 2 is negative 4, minus 3, negative 7. Okay, so when I plug a negative 2 into f, I get a negative 7. So now I'm going to turn around and take that negative 7, and I'm going to plug it into the inverse. I'm going to do that up here. So I get negative 4, right? Negative 7 plus 3 is negative 4 over 2. That is negative 2. All right, so here we can say, hey, that's interesting. If I plug a negative 2 into f, I get a negative 7. If I turn around and plug the negative 7, right, which is the output over here, into f inverse, right, I get that negative 2 back. All right. And we're going to see that, right, that's not a coincidence at all, right? That is exactly what the relationship is between a function and its inverse. If I take a number and I plug it in, right, and get into a function and get an output, if I take that output and plug it in to the inverse, it's going to give me the number that I plugged back in. So basically, they undo each other. All right, so just to keep verifying this, f of 4 is 2 times 4. Minus 3, right? I'm taking the 4 and I'm plugging it in here. So I get 8 minus 3, which is 5. Okay. All right, and so if you believe what I told you here, right, in the previous one, then we really don't even have to work this out, right? We know that f inverse of 5 is going to be equal to 4, right? Because when I plug the 4 into f, I got a 5. If this is what I said about the inverse is true, when I take this 5 and I plug it into the inverse, I'm going to get that 4 back. And of course, we should go ahead and verify that and work that out and make sure that it's true. So if I plug in the 5 into f, right, inverse, I get 5 plus 3 over 2. That's going to be 8 over 2, which is 4. Okay, and just like we said it would. All right, one more example here for this one. F of 10, if I plug a 10 in here, I get 2 times 10, which is 20. 20 minus 3 is 17. All right, so I get 17. Now they want us to calculate f inverse of 17. Again, we know, right, that if, again, what I said is true, that's going to come out to be 10 when I do that. Right, because of this fact over here and the fact that they're inverses of each other. But we might as well go ahead and check it out, right? If I plug a 17 into f inverse, we get 20 over 2, which is 10. Right? Just like we said it was going to be. So this is the relationship between a function and its inverse. If I take any number in a function's domain and plug it in, right, I'll get some output. right? As long as the function has an inverse, right? If I take that output and plug it into the inverse, it's going to give me, right, that input back. It also works the other way, right? If I take a number and I plug it into the inverse, right, and I get an output, if I take that output and plug it back into the original function, right, I'll get that input back. And really what that says, right, about this is that f is the inverse of f inverse, okay? So that's it. That's the relationship between a function and its inverse. And that's what we're talking about here, okay? All right, we're going to do this same problem, right, in a couple of different ways. This is probably the most important way, but we will talk about the others as well. All right. So next up, right, if I have a function written in ordered pair notation, I want to find f inverse of 6. Okay, so f inverse of 6, right, what I would do is to look through until I found a 6, right, in there, right? And so f inverse of 6 is equal to 4. Okay, and that's it. All right, you can see that if we were going the forward way, if this function is called f, right, then f of 4, right, this is, we think of the input, right, and the output would be 6, like here. All right. So f of 4 equals 6. That's going to make f inverse of 6 equal to 4. Very similar here, right? Here I've got a function that is written in the table or the diagram, arrow diagram format. I want to find f inverse of 8. So, right, I would look over here, and here's the 8. Okay. And then just follow the arrow backwards, right? And it's a 4. So f inverse of 8 is equal to 4. Okay. Similarly, you can think about it the other way that we have also been thinking about it, right? If you just find f of 4, right? So start over here in the domain with the 4 and follow the arrow, right? That would give you an 8. So basically that means if I had the formula for this function and I plugged in a 4, I would get an 8. And again, that makes, if I take this 8 and plug it into the inverse, I'm going to get this number back, right? So, all right, next is the table format. And again, this is really pretty straightforward if you have your function written in this format. What you would do is find, we want to find f inverse of 2, right? So what we would do is look through the output values, right? So you find a 2, and we can see there it is right here, right? And so that would be 11. And again, that's basically because, right, if we read the table the normal way, right, f of 11, right, is equal to 2. The input value is 11, right, and the output is 2. So that means for the inverse, right, if I have an input of 2, it will give me this 11 back here. Okay. Okay, so then the final way that we are going to find inverse function values, right, is with a graph. Okay, and how this works is we got to have to completely use the graph. Let me. So I want to find f inverse of -3, all right? And so what I would do is find -3 on the y-axis. It's right here, right, on the y-axis. And then I would go left or right, horizontally until I get to the function, right? And so I get right here. That's where the function is, and then go straight up or down, right, to the x-axis. And you can see I would be at -4 right here. Okay, so f inverse of -3 is negative 4. Likewise, right, that is the reverse of the way that you would normally do it, right? And how you would normally do it is to say f inverse of minus 4, right? If I want to find f, or sorry, not f inverse, but f of minus 4, I would locate minus 4, right, on the x-axis and then go straight up or down, right, until I hit the function. Okay, so here's where the function is, and then look over and get that y value would be negative 3. So that's how you would do it normally, right? But we want the inverse, so the process is backwards, right? Or once you find this fact, then you just reverse, right, the x and the y and get the fact for the f inverse, okay? All right, let's do f inverse of 0. All right, so what we would do, right, the process is we would look on the x-axis, on the y-axis rather, right, for 0, and that's right here. And then we would go left or right until we hit the graph, which is right here. And then we would go up or down, right, until we got to the x-axis. Well, it just so happens that we are already, right, on the x-axis, right, and so there's nowhere to go. We're already here. And where are we on the x-axis? We are at 2, right? So f inverse of 0 equals 2. Likewise, going the forward way, right, you would find 2 on the x-axis, right? Right, and then go to where the graph, go up or down until you hit the graph, and I don't have to go anywhere because I am right already on the graph, and then go over to the y-axis and see where you are. So you can do it either way. You can just use the reverse process to just go ahead and knock it out. You could do the forward process, right, and then reverse this to get what the inverse was. All right, last example is f inverse of 1, right? So we would find 1 on the y-axis. Here it is, right? We would go left or right until we hit the graph, which is right here. And then we would go up or down, in this case down, right, until we hit the x-axis, and then we would look where we are, right? So f inverse of 1 is equal to 4. Now, likewise, right, if you went the other way, it would be f of 4 equals 1. So you could do it either way. Just run through the process and get the answer directly, or do it, you know, find the function value itself, f of 4 equals 1, and reverse it like this. All right, so that's how you would find inverse function values on the graph. Right, and so that's it for this video. In the next video, we will talk about finding the functions themselves, okay, not just some values.